Hi, my name is Mikkel Jansen. I'm a senior scientist fermentation with the DSM Biotechnology Center. What I would like to do here with you is to give you some more insight in the considerations for industrial process development and illustrate that with the best practice for succinic acid production. But first I would like to spend a few words on the company I work for, DSM. DSM is a very dynamic company that, besides having an economic viable business, also wants to provide brighter lives to people not only today but also in the future. To accomplish this, DSM uses its unique competences in both life sciences and material sciences, and with that creates synergy. DSM really has a long track record in biotechnology. It started basically around 1870 with the yeast and spirit plant in Delft for the production of yeast and alcohol. Since then, more biotech-related products have been developed and also commercialized. The genetic tools developed since the 80s enabled us to use these for the development of our own products such as antibiotics, vitamins, etc. In the last decade, since 2005, DSM initiated a large program in the field of industrial biotech related to the use of renewable feedstocks for the production of fuels and chemicals. Succinic acid is an example of that. Looking at the history, DSM originated 1 century ago as a mining company in the Netherlands and transformed itself throughout the decades from a mining company into a chemical company. And currently we call ourselves a life sciences and material sciences company. DSM has become a very international company, as you can see in this graph. We are located all over the world. Recently, we focus more on Asia and Latin America, becoming important, new and growing markets for us. So this is some background information on DSM. From now, we will focus on succinic acid. You might wonder why we are interested in succinic acid. Well, succinic acid is a very versatile molecule and can be used for many applications. Currently, the majority of succinic acid is produced via a petrochemical-based process and is used for food, pharmaceuticals, coatings and metal plating. But we at DSM aim for a bio-based process which can replace the traditional chemical process. By using an agricultural feedstock as substrate, we would be able to produce biosuccinic acid, or as our product is called, biosuccinium. For this biosuccinium, we foresee many different applications. The first application we focus on would be the biodegradable plastics, called PBS, in fact a copolymer of succinic acid and butanediol. This is a new product which can be used for agriculture filming, food packaging and multiple other applications. The second application we focus on is polyurethane. This product already exists. However, now we want to replace the used adipic acid, which is petrochemical based. So with succinic acid, we would like to green this product. Applications are also very diverse in this field, like shoe soles, car seats, but also isolation foams. The third product we are focusing on, which can be successful if cost prices are low enough, is butanediol. Succinic acid can be used to create these products, which has already a big existing megaton market in itself. So that would open up much bigger volumes for biosuccinium. Succinic acid is used in many different industries, but currently the market is relatively small with a yearly demand of approximately 35 kiloton. However, when a bio-based production process for succinic acid would be made available and successful, we foresee a potential market in 2020 of around 2 megaton. As the potential is present to become a bulk chemical, we decided not to develop and produce this alone. Therefore, we joined forces with a partner that has basically the same vision as us, and preferably with complementary competences to create added value. We found that partner in Roquette. This company is one of the top manufacturers in the world for renewable starch and starch-derived products and has already experience in biorefineries. So how did we approach this bio-based succinic acid production project? Really, at the start of the project, targets for the production process were defined. The first target is to develop a fermentation-based process that is at least cost competitive with petrochemical-based succinic acid. Otherwise, there would be no demand. Secondly, we want the most sustainable process possible with the lowest carbon footprint. Thirdly, we need a high-quality product, essential for our envisaged polymer applications. To accomplish this, we choose for a fat batch fermentation process with renewable sugar as feedstock. To realize the lowest possible cost, we defined several key performance indicators that impact the overall cost price, also known as cost of goods. Some of these KPIs might already sound familiar from previous units. A first important indicator is the process yield. This includes the succinic acid production yield, so the net conversion of sugar into the product of interest. The cellular growth, being the amount of microbiomass needed, and the downstream process yield. Secondly, there is productivity, dependent on the applied biomass concentration and the specific production flux QP. A third important indicator is the final succinic acid concentration in the fermenter. And the fourth element is the amount of titrant needed to control the pH in the fermentation process. In the next unit, I will explain more how important these performance indicators are, how they interact, and how to choose your microorganism for production, crucial for your industrial process development. Finally, I will show you some results we obtained in this project. So see you next unit.